Hello students, in this video I am going to teach you how to find the derivatives of certain functions using quotient rule. In my previous video we saw how to use the product rule, and in this video we are going to see the quotient rule. So let us say a function f of x is in the form h of x over g of x. Suppose if we have a function of this form, then to find the derivative of f of x you need to use the quotient rule. Now the quotient rule says that f dash of x, that is the derivative of f of x, is nothing but g of x, which is the denominator, multiplied with h dash of x, that means the derivative of the numerator, minus h of x multiplied with g dash of x, that is the derivative of the denominator, divided by g of x squared. So let me explain once again. So to find the derivative using quotient rule, you multiplied the denominator with the derivative of numerator minus the numerator multiplied with the derivative of the denominator, whole divided by the square of the denominator. So this is the quotient rule. So let me explain it using a problem. Okay, let me erase this. Let's consider a function. Let's consider a simple function. F of x equals, let us say, x plus 1 divided by x squared plus 1. Okay, I'm going to find the derivative of this function. So according to the quotient rule, f dash of x equals, we multiply the denominator, that is x squared plus 1, with the derivative of the numerator. Now the numerator is x plus 1, so the derivative is nothing but 1 plus 0 minus, now I keep the numerator as it is, that is x plus 1, and I multiply that with the derivative of the denominator, and the derivative of the denominator is 2x plus 0, whole divided by the square of the denominator, which is x squared plus 1, the whole square. So if I simplify the bracket, if I open the bracket, I'll get x squared plus 1 minus 2x squared minus 2x divided by x squared plus 1, the whole square. So the final answer will be it will be minus x squared minus 2x plus 1 divided by x squared plus 1, the whole square. I'm really sorry, I'm using my hand. I don't have a stylus as of today, so I'm using my hand. So I hope it is quite clear to you, right? Okay, so let me explain the quotient rule with another problem. I'm sorry, let me erase this. Okay, let me take another problem. Let me take a function, a combination of an algebraic and a trigonometric function. So let's say x squared plus 1 divided by sine x. Okay, let's say I want to find the derivative of this function. It's very simple. F dash of x equals denominator, which is sine x, multiplied with the derivative of the numerator. The derivative of the numerator is 2x minus the numerator, x squared plus 1, multiplied with the derivative of the denominator. So the derivative of sine x is cos x, so cos x, whole divided by sine x, the whole square, which is nothing but sine square x. So the final answer is 2x sine x minus x squared cos x minus cos x divided by sine squared x. So this is the derivative of the given function. Okay, let me take another example. Okay, let me hit the heading once more, quotient rule. Fine. let us say okay, let us do this function. I'm going to take a slightly difficult function, f of x equals slightly more challenging problem, x squared divided by x plus log x to the base e. Okay, now I'm going to find the derivative of this function. I think the squared is 2 is not very clear here. Okay, let me erase this. So x squared. Okay, now f dash of x equals, I will multiply the denominator, which is x plus log x to the base e, with the derivative of numerator, which is 2x, minus, I'll multiply the numerator, which is x squared, with, I think there's no space here, so the derivative of the denominator, which is 1 plus 1 by x. Okay, whole divided by x plus log x to the base e, the whole square. And of course, you can further simplify it and get the final answer. Okay, so let me do another problem. Let me take, let us say, okay, f of x equals e power x divided by e power x plus 1. Okay, 1. So f dash of x equals, so the denominator, which is e power x plus 1, multiplied with the derivative of numerator, so derivative of e power x is e power x, minus numerator, which is e power x, multiplied with the derivative of denominator, which is e power x plus 0, divided by e power x plus 1, the whole square. So if I open the bracket, I'll get e power 2x plus e power x minus e power 2x over e power x plus 1, the whole square. So I can cancel this and this. So the final answer is e power x upon e power x plus 1, the whole square. So that is the final answer. Okay, one last sum to explain this concept of quotient rule. Let me take, let's say, fine. Let me take this function, f of x equals, I have log x to the base e divided by x plus 1. Okay, now f dash of x, as I said, the quotient rule is multiply the denominator with the derivative of the numerator, which is 1 by x, minus multiply the numerator with the derivative of the denominator. We know that derivative of x plus 1 is 1 plus 0, so it's simply 1, whole divided by x plus 1, the whole square. So the final answer is 1 plus 1 by x minus log x to the base e, whole divided by x plus 1, the whole square. Okay, so I hope the product rule is clear to you. So let me see whether I can give you a slightly more challenging problem to explain this concept. Let's say clear all. Let me type a function. I'm just searching for a function in my textbook. Okay, fine. I'm sorry for the delay. Let me just find whether I can find a problem for you. Okay, let me do this sum. F of x equals e power x plus x upon x plus 1. Now f dash of x is the denominator, which is x plus 1, multiplied with the derivative of the numerator, which is e power x plus 1 minus the numerator, which is e power x plus x multiplied with the derivative of the denominator, which is 1, divided by x plus 1 the whole square. So let me open the bracket. I get x e power x plus x plus e power x plus 1 minus e power x minus x upon x plus 1 the whole square. So I think I can cancel this and this, I can cancel this and this, so final answer is x e power x plus 1 upon x plus 1 the whole square. Okay, so this is how you use the quotient rule. Yeah, thanks for watching this video and I hope you like this.